ಹಾಯ್ ಅಂತಾರ ಹೆಂಗ ನಾವು ಚೆನ್ನಾಗಿ ಬೇಕಲ್ಲ.
One of you have asked difference between temperature and heat. Temperature is the effect of heat. Suppose heat energy flows into a matter. Once the heat energy goes into a matter, temperature increases. Temperature represents kinetic energy of molecules. Suppose if heat energy goes into a body, then kinetic energy of molecules will increase. As kinetic energy of molecule increase, temperature increases. What is the difference? Temperature is the effect of heat. Okay, here we can say temperature change is a result of heat flow inside the body. Temperature, you can say it is the measure of average kinetic energy of the molecules. As more heat is a form of energy, but temperature is not a form of energy. It is temperature is a tool to identify the average kinetic energy of molecules. Temperature represents the internal energy of the represents, but temperature is different quantity. Here heat is a form of energy. Temperature is a physical quantity which measures the average kinetic energy of molecules, but temperature is different, heat is different. Temperature is the effect of heat. If heat goes, then represents the temperature. Temperature change happens, right? So PV is equals to nRT is already you know it. It is the ideal gas equation or perfect gas equation. Here, this equation, here what is R? It is a universal gas constant for 1 mole of gas. Okay. Now, in molecular perspective, moles way, okay, this is there, 1 mole, 2 mole, like that. If suppose 10 molecules are there, 15 molecules are there, like molecular perspective, if you want to write, what we do here, R is a gas constant for 1 mole. For 1 mole, R is a gas constant. Okay, what is its value? 8.31 joule per mole per Kelvin. If you divide it by number of molecules present in 1 mole, what is here? Na means what? Number of molecules present in 1 mole of gas. 1 mole of gas constant divided by number of molecules present in 1 mole. If you do, you will get one more constant. What is that one more constant? Boltzmann constant. So this is the where K is what? Boltzmann constant. This is for 1 molecule. This is the gas constant for 1 molecule. Even you can have its value if you write this as 8.31 divided by 6.02 into 10 to the power 23. If you divide it, you will get K value as 1.38 into 10 to the power minus 23. This is the value of K. So what is the unit of R? Unit of R will be joule per mole per Kelvin. Okay. If you want, I can even tell you in the next class how R is equals to 8.31. I tell you in the next class. So if what is the unit of K? It is only joule per Kelvin, because here joule per mole per Kelvin is there. Here already 1 mole is there. So if you divide it, joule per Kelvin is, you get the unit for K. What is here? If you K value, you know R by this is K. Then if you write for R, what is R? K, Boltzmann constant for one molecule. This is a gas constant for one molecule, and this is Avogadro's number of molecules, and this is gas constant for one mole, and this is gas constant for one molecule. In any problem, suppose molecule wise they talk, then better you have to, this equation itself I'll write PV is equals to N in place of R, K, Na, and here is T. Then number of moles into Avogadro's number. What is this gives here? PV is equals to number of moles into Avogadro's number of molecules. This gives total number of molecules present in the gas. You have got some gas like 10 to the power 10 number of molecules are there, 10 to the power 20, whatever total number of molecules are in. Number of moles into number of molecules present in 1 mole, that gives total number of molecules. This is K here, and this is equation will help you molecule wise, bit microscopic. This is bit microscopic than this. Here K is what? Gas constant for one molecule, and N is total number of molecules present in the gas. This is another form of ideal gas equation. So different forms of ideal gas equation will help in different situation. So circumstances will make you to use which equation, right? If you blow air into the balloon, what you are doing there? You are adding new air molecules. You are changing the mass of gas. Suppose here balloon, Boyle's law will applicable, like volume increase, pressure decrease will applicable for given mass of gas. As long as mass of gas is constant, temperature is constant, then ultimately volume increases, pressure decreases, volume decreases, pressure decreases, that is it. But what you are doing through mouth, you are adding more number of molecules to the balloon, then you are bringing variation in the mass of the gas. Then there is a violation that happens how you take the system. Okay, you keep the system mass of the gas same. If you vary the mass of the gas, then there comes even pressure increase, volume increase. There is that you are driving the situation to what you say. That will not happen. It will boils are applicable only if the mass of gas is constant. Linear expansion, just I told you, it's in brief. I told you, suppose if this is one, here length is greater than breadth, this width, this size is very less than this size, then we can say linear object. When you say linear object, its length is more than its other dimension. If length is more than this side, this, then we say linear object. At that time, more atoms, more matter is there in linear ways, then more matter is distributed in linear way, linear manner. Then what will happen? Because of expansion, because of average separation between the atoms will contribute, more atoms will contribute such separation. More atoms are which side? That side. More matter is which side? That side. Because of contribution from all, each separation between each atom increase. Overall contribution. Initially length is more. If you give heat, increase in length is always directly proportional to initial length. Suppose initial length is 2 meters. If you increase it by 1 degree Celsius, assume it will increase its length to say 10 to the power minus 5 meter. Suppose initial length is 2 meter. If you increase it by 1 degree Celsius, assume the length will increase by very less, 10 to the power minus 5 meter. Suppose the same material, if you take initial length as 4 meter, if you increase again the temperature 1 degree only, don't justify, just same temperature change you do, it has been observed increase in length will be more than this. It may be 2 into 10 to the power, like just roughly I am telling. So increase in length in the second case will be more than first case, as the initial length is more. Even for the same rise in temperature, increase in length will be more for the case where initial length is more. It's because as you give more and more temperature, more and more heat, then separation between atom because of vibration. I told in brief, average separation goes on, increases. Altogether, total expansion will increase. Okay, so length will increase if you give heat as we increase the temperature. That's what linear expansion. So that even depends on rise in temperature. More temperature if you give to it, then more vibration comes, more separation between the atom happens, more expansion happens. More you increase temperature, more the vibration, more the average separation between the atoms, altogether expansion will be more. The simplest way, don't go microscopically, just here what we have is increase in length is directly proportional to initial length, increase in length is directly proportional to increase in temperature. So this is what we have done it. Increase in length is even directly proportional to increase in temperature. So if you combine in one equation, increase in temperature, increase in initial length, increase in temperature. This is LF minus Li is what? Increase in length. This is initial length. This is increase in temperature. If you remove this proportionality sign, there comes one more constant. This is what indicator of nature of material. Which nature of material is also important. In not at over in the next class, we still go some more about it. Next class.